Hi guys, my name is Ivo and I'm from mytestedasp.net. First, a little bit about myself. I have been working as a CTO in a large software development team. I have been teaching modern and C# and JavaScript technologies, and in my free time I tend to write quite a lot of code. You can find me on GitHub if I will kind of. Most of my projects are open source libraries for the ASP.NET framework, and for example this one is a fluent testing library allowing you to easily assert your controllers, routes, models, services and more. If you find these projects useful, you may give them a star, you may for them, you may include them in your projects as you wish. Recently I decided to start video series about my developing experience with all my open source projects because they turned out quite huge and they turned out quite difficult at times. So I learned a lot of useful C# techniques by developing these projects, so I decided to share my knowledge with the world, hopefully you will learn something from me. In my last couple of videos I have been showing one of the famous project structure with ASP.NET framework, ASP.NET web applications, and that's the folder by type project structure. It's useful with smaller applications or with microservices where your servers do not have a lot of controller logic in them. So in my previous videos we covered how to clean up the initial project structure, how to separate the web application. We saw the data layer, we saw the service layer, and now we need to finish our controller layer so that our project structure is finalized. Another famous project structure is folder by feature, which is essentially better with bigger monolith applications, and I will show it in one of my future videos. Okay, so continuing from my previous video, if you haven't watched it, I will provide a link in the description down below. Okay, what we need to do now is to implement the controllers, and our main idea here is to make the controllers to be as thin as possible. They should not have any logic in them, which is logic besides request and response processing. All business related logic should be extracted to a service. For example, the article service is extracted here. We don't make link queries in our controllers. We don't execute database save changes methods in our controllers. We delegate that to our service layer. We don't send emails, we don't extract PDFs, we don't parse Excels and so on. All that logic belongs to the service layer. The controller is only responsible to get the request data, to validate it, and to return a response. All the request data goes to the service layer, and the service layer decides what kind of business logic to execute. So for example, if I want to add a create action here, for example create, initially people may try to use the database directly here. That will be fine, it will work correctly, but then our controllers will start doing more than one thing. They will start using database, they will have business logic, and they will process requests and responses, which is essentially breaking the solid principles. So we need to extract the creation logic into a service. So what we need to do here is we need to get the data from somewhere. Typically we will have an action returning view which returns the form and displays it to the browser. We're not going to implement the HTML part because this video is not about how to create forms with ASP.NET. It's about how to split our logic into different layers. So we would have an HTTP post method, and typically we will have some sort of model here which will be responsible for all the data we receive from the form. So what we're going to do, we're going to create a form model. I like to create a folder for each data model like we did here in the service layer, because usually we will have create article model, edit article model, and so on. We will have a lot of models created for our for each database entry. So I'm going to create article form model. My typical naming convention is I have view models that render something on the view. This is a view model. I will have a form model when I receive data from a form. I will have service model, that's a model which is returned by a service. And if I am creating an API, I will have a request and response model. And you don't need to follow any of these conventions, but it's easier to understand what each class is doing and what each class is responsible for. For example, this class obviously is responsible for returning data from the services. This class will be responsible for creating an article from a form, and so on. It will be easier for you to find your classes and to understand what they are doing. Okay, a typical form may have title and description. We should have some sort of validation here, and we may reuse the same validation we used here. That's the coolest thing about extracting the validation constants. We can reuse them everywhere we like. So I'm going to reference the data, and I'm going to say using static data validation data validations article, and max length, title length, and max description length. Okay, great. There's something wrong here. Let's rebuild that. Okay. I will make the creation of the articles only for authorized users, just because my service layer expects an author ID. So in order to provide it, I will need an authorized user. Another thing which is necessary is validate anti-forgery token, but we should register that globally, so I will enter it in a minute in our startup class. First, let's provide the article form model. Let's create article form model, and it's found in using models.articles. So what I need to do now is I need to just check the model state. If model state is valid, then I will say my article service does not have a create method in the interface, so I will introduce it. So I'm going to write create, and I will say model.title, model.description. I need to get the current user ID, and that can be done with this.user.find first claim. Not sure which one to use. Find first claim type. Should check what was the needed code for that. Claim types. Okay, that's the easiest way to get the user ID from the user, but I prefer to have that extracted because I will be using it a lot in my application. So what I do is I will create an infrastructure folder here, infrastructure folder, and I say claims principal extensions. This class should be static, and public string, static string get user ID, this claim principal. And good, we extracted that logic, so we can easily provide it by calling this .user.get user ID. Okay, I need to make the method async, and it should be working now. So var article ID should be returned from this service, and now I can return redirect to action, name of details action, for example, if I have such action, and since I don't have it, I'll just write it down. If the model state is not valid, I should return the same view with the same model. So essentially, this controller action validates the request. You may extract that to action filter. I will show how you can do it in a future video. Then you execute the business logic through the service layer, and then return any kind of result which is suitable for your case. In most cases, when we create an entity we redirect to action, you may use expression trees here. I show it in another video how to remove the magic string here. I will provide a link in the description. And if the model state is not valid, I will return view. But my action is quite thin. I don't have any business logic here. I have request validation, service layer dispatch of that request, and responses. If my controllers become a lot, I will separate them to different folders. For example, articles folder, users folder, and so on. Just like I'm doing here with my models. Additionally, the other way is to use areas. Either way it's fine. I typically separate my controllers to different folders as it's easier to find the controllers in my project. Okay, let's register the validate anti-forgery token. That's a little bit easy. Options, post options, filters, add. So instead of adding the options here, I will extract MVC builder. The idea here is to extract these calls with all the options to the MVC framework I have in a separate method, so that I don't pollute the startup class and all my configuration to be extracted, just like we did with the get default connection string. We may do that with the identity too, but as you wish. So I'm going to extract these and put them here, and I will register the filter, which is new auto validate anti-forgery token. there's some mistake in the name. Yeah, I need to code the attribute and I need to make that auto-validate anti-forgery token. Yeah, okay, I found the name after 50,000 errors, but apparently Microsoft were not consistent about the naming of this attribute and left the F letter to be in lowercase. I don't know why, but for some reason, maybe it's a mistake from them, but validate anti-forgery token is with a capital letter. Okay, never mind. Good, so when we register the auto-validate anti-forgery token, then we no longer need to provide this attribute on our controllers. All post actions by default will have the anti-forgery token validated for us because of this startup filter. Okay, so the whole idea here is to have controllers being as thin as possible, and their whole task is to get the model, validate it, pass it to the service layer, and return a result. Our controllers should not do any other logic besides that. Getting the request, validating it, and passing it to the service layer, then return result from that service layer. Cool. Now I'm going to show you how to implement a full CRUD. So if we have an update, what we would like to do is we would like to, so we have read, we have create, we need update, so we're going to have edit service, I will return true or false whether or not the edit was successful, and I will not allow editing of author IDs. So if you create an article, it stays yours. That's of course is my business logic, but I will do it like this. Okay, so then I need to implement that. I need to implement the edit action. So what I'm going to do is I'm going to find the article. I'll say find by ID. We have an async action, so yep, good. Okay, if article does not exist, I will return false. Otherwise, I will update the article with the provided values. Good. So I will need another method which shows which returns true or false on whether or not the article exists in our database. So I'm going to implement that also. I will need that method in the get edit action. Just say I need with this data articles any async only article with, do I have an article with this ID? Cool. What I need then is to create an HTTP get and create an edit article form model, which idea is to have the same as create article form model, but with the actually I don't need the ID. The ID is coming from the root value, so I'm going to delete that and I will just leave the article form model to be my main class. It will work for both forms, for create form and for the edit form. Okay, so I will need to change a bit my article service because I want to be able to edit my article only when I'm the user who created it. Otherwise, it should not be allowed. So if I go to the article service, I will say it should exist for both the ID and the author ID. So if I add it here, I will need my article to have both these conditions met. Otherwise, my article does not exist and I'm not allowed to edit it. So this data exists, ID this user, get user ID. If such article does not exist, I should return not found. Otherwise, I should return the view which is responsible for editing the article. As you can see, this action is also getting the request data, is passing it to the service layer, and it returns a result based on that service layer response. So essentially my action remains thin and my controller does not implement any business logic. So the post action should be public async task from iAction result and ID article form model, and I would have the same check if I am able to edit the article If not, I should return not found. Then I should say that articles.edit this ID with this title and this description. Then I should return view, but first I need to validate the model state. And if the edit is successful, I should return some sort of redirect. If the edit is not successful, then I should return the same view with the same wrong model. Okay, let's write the details. I will need another service layer model, article details service model. The article details service model will have some of our article data, for example, type of description, author, and so we will need the ID, we will need the description, we will have the date time, and we will have the author as a string. That will be enough. Then the article service should return article details service model, and we need to implement that method. So I will just say await this data. This is an async method, so I'll need articles where article ID equals the provided ID. I need to select it. My article goes to article details service model, and then I should call first or default async. In my next video I will show you how to remove this boring code by attaching automapper. We will skip code like this: title equals title, description equals description, created on equals created on, and so on. Great. We will now need HTTP GET method public async task from iAction result details by ID, and what I need here is to get the article, this articles.details by ID. I need to await that. If the article is no, should return not found. Otherwise I should return the view with the article service model. Again, my controller does not do any business logic, it just gets the article by the request data. If it's found, it returns a view with it, otherwise it returns not found. Details. And now I can provide a strongly typed solution to these redirects. And the last action we want to implement here is we want to implement a remove action task from bool remove by ID or delete, doesn't matter. Article equals this data find async if article is not found, return false, otherwise this dot data remove article save changes async and return true. You may wonder why in the edit action we check for no just to be safe. Since our controller first tries to find the article in the database, we may skip this no check, but it's a good idea to always have an error handling in your code, so it's better to be defensive and to skip some unnecessary exceptions if someone else decides to use the article service in another controller and decides to skip the exists action for some reason. For example, if we create an admin article controller, it may reuse the article service, but it may not need to check for the exist method because admins could edit all our articles and we don't need to check whether the article has the same user ID as the admin, so we will not execute this check. So it's a good idea to still validate our service logic because we don't know how our controllers are going to execute this code. So it's a nice addition to have a no check here. The same reason I have a no check here, but I won't use it because if somebody decides to delete an article, he should be the author of that article. So public task from iAction result delete by ID. I should have the same check here, otherwise I should return view. and the view should ask the user for some confirmation. For example, are you sure you want to delete this article? And if the user hits yes, I'm completely sure, we will redirect him to this confirm delete action. And if the article exists, we are going to call the delete method here. Which will delete the article from the database. And now I'm going to return a redirect to name of all, for example. We don't have an all method. Oh, it's the index. Okay, let's create it like this to make it valid. And let's redirect to the index action after deletion. So as you can see, my controller is completely thin. It does not contain any logic. It uses abstractions over the article service, and the whole all tasks this controller is doing are just request processing and validation. For example, the model binding here, the request validation, for example, the HTTP post and the authorize attributes. It dispatches different tasks to the service layer. For example, check whether the article exists, check whether the article can be edited, edit the article, and so on, and returns responses. This is how our controllers should look like. They should not have a lot of code. They should have only the minimum amount of request and response processing. That's the perfect way to write ASP.NET Core controllers. And again, if for some reason your controllers become a lot and you have, for example, like 50 controllers here, that's not a good sign. You should either use the other project structure, which is folder by feature, or you should split your controllers into folders. If you split them into folders, you will be quite happy with this project structure. And I believe that's it for now. In the next video I will show you. It will be the last of this series and I'm done with this project structure. It should be enough for you to understand how to separate the different tasks of your web application. And in my next video I'm going to show you how to write additional goodies with AutoMapper and skip a repetitive code like this. That's when our models become bigger, and in normal applications we have quite a lot of properties here, and it's quite boring and troublesome to write such code, and we should leave that to the AutoMapper. But that's for the next video. If you liked this video and liked my content in general, I'll be more than happy if you share it with your friends or leave a comment below or just hit the thumbs up button. If you decide that you're interested in my open source project, you may give them a star, or if you really want to support me, you may become a backer or sponsor on the Patreon or Open Collective pages. Some people already did and I'm extremely thankful to them. Here and here. And if your company is looking for more exposure, they may become sponsor to my videos and my projects. Current sponsors are Smart IT and Softuni. So if you have that opportunity, I will be very thankful. Bye.